Okay, so here we have three simple integrals. I want to call them the big three that we should definitely know about. These are integrals that show up many times whenever you're doing integration, especially like trig substitution. So keep that in mind. You need to know, in my opinion, these three. Memorize them. You got to memorize them. So let's talk about the first one. This one's going to be pretty easy. It's just a simple substitution, or you have to introduce something to it. This we probably already know. And then we have this one right here that's going to require some more time. So let's talk about number one. If we're going to go ahead and solve the integral of secant of dx, we're going to go ahead and introduce something to the top and bottom. And that's going to be secant x plus tan x. And then we're going to do the same thing on the bottom here, secant x plus tan x. So we're going to get this integral right here. We're going to have integral of, let's go ahead and distribute this secant x into this one, and then we'll distribute it to the tangent as well. That's going to give us secant squared x plus secant x tan x. And on the bottom, we just have the value that we introduced, secant x plus tan x with respect to x. So the idea here is we introduce something so that we can go ahead and make a u substitution. This is going to be our u value right here. We're going to make u equal to secant x tan x, and then we're going to go ahead and find our differential. We have du equals, the derivative of secant x is secant x tan x, should probably put an x there, plus the integral of tan x. And I realize that this should have a little plus sign right here. Sorry about that. So tan x, a derivative of that, we already know that's a simple secant squared x with our dx. So again, this is a differential that we need. And what do you know? That is exactly what we have on top here. So we already have our du. So now our integral is going to become integral of, we have du over u, which we already know this is natural log of u plus your cheese. We'll go ahead and substitute the value of u back in, and we get that the integral of secant x dx is going to equal to the natural log of secant x plus tan x. And don't forget your plus cheese. And that is the first integral that we should know, my friends. Well, number two is kind of a joke because it's the integral of secant squared x. I mean, we already know, or we should know, that this is tan x plus our cheese. Let's not forget, if you wanted to double check that, take the derivative of tan x, and that's going to be secant squared x. So there's really no work for this one. So let's go ahead and erase everything else, and let's go ahead and talk about the last one. Number three, let's go ahead and solve my favorite, or actually not my favorite. There's a lot of favorite integrals that people have. But we're going to go ahead and solve this one. So let's go ahead and start it off by writing the original integral that we have here. And we're going to make this equal to something. And what is that something? Well, we're going to use ultraviolet voodoo. In other words, integration by parts. So we're going to make our u, we're going to make that secant x. And we're going to make our du equal to secant x tan x dx. Now, I guess I should have written here that, of course, there's three of them. So one of them, our u was a secant x. So what's left over, which is our dv? Well, that's secant squared x. So we have dv is equal to secant squared x dx. And now we have v is equal to the integral of this, which we know is tangent. Okay, don't forget, integration by parts is uv minus integral of v du. So we have uv, we have secant x tan x minus integral of v du. So we have secant x tan squared x with respect to x. That should be a squared right there. Make that a little nicer. Okay, so think about this. Pause the video and think about how we can continue integrating, because we still have to integrate this part right here. What should we do, huh? What should we do? Well, before we continue, let me just erase this part just so we can leave some space here on the board. Check this out, guys. We're going to go ahead and rewrite this. But before we do that, keep in mind, we should know this, in my opinion, that 1 plus tan squared x is equal to secant squared x. This is a Pythagorean identity. So let's go ahead and bring the 1 to the other side, leaving us with tan squared is equal to secant squared minus 1. Now, why did I do this? Because this tells us this particular integral it should equal all this thing that we wrote minus integral of secant x times the tan squared that we had here. So that's secant cubed, secant squared x minus 1 dx. I'm definitely getting ahead of myself here. Because now we're going to go ahead and distribute the secant to the secant squared, and we're going to distribute it to the minus 1. So look at what we have. We have the original stuff equals secant x tan x minus, and now let's go ahead and distribute this. So we have integral of secant cubed x dx, and I'm going to separate this into two integrals already. And then when we multiply the secant x to the negative 1, that's negative secant, but you still have the negative on here, so this is going to become plus integral of secant. My God, good thing we covered this one, right? This right here, this is negative secant cubed x. How about we add it to the other side so that we get 2 integral of secant cubed dx is now equal to secant x tan x plus the integral of this. Well, we already know that. That's natural log, absolute value of secant x plus tan x plus our cheese. Final part is to go ahead and divide everything by 2. I'll just do it on the last step, I guess. So we have integral of secant cubed x should equal 1/2 times this entire thing. So maybe we can do 1/2 times this entire thing, or why not just do secant x tan x divided by 2 plus natural log of secant x plus tan x plus c. You can divide the 2 or the c by 2, but it's just going to become a constant. And one thing I forgot, I'm sure someone is already yelling at the screen that I should have gotten this. I have the divided by 2 here. And that, my friends, is the integral of secant cubed x. A lot of people always say that a good way to memorize this is that this is basically the average of the derivative of secant and the antiderivative of secant. Because the derivative of secant is secant cubed plus the integral of secant x, and then you just divide it by 2 because it's the averages. So it's kind of cool to do that, but memorize this one right here. And that's all I'll have for today.